Hi everyone, I'm Manali from Espressif Systems and I work in the backend team of ESP RainMaker. Today we are going to talk about extending RainMaker. But before going to what extending RainMaker is and how in what ways can you do it, let us see what ESP RainMaker is. So ESP RainMaker is Espressif Systems cloud offering wherein it offers an end-to-end solution for all your IoT products. Because of this, you can focus on your innovative core offerings and we focus on the common technical functionalities. So let us see what Rainmaker architecture is so that we know what is offered as part of ESP Rainmaker. So ESP Rainmaker comes with device SDKs. It comes with voice assistants in the form of Alexa and Google Voice Assistant, an admin dashboard to manage the Rainmaker service, mobile apps for Android and iOS for your end users to connect with their devices, and one cloud infrastructure which is hosted on your private AWS account. All these components interact with each other to form the complete ecosystem. So smart IoT devices interact with AWS IoT MQTT broker to connect to cloud, and voice assistants, admin dashboard, and mobile apps, which are nothing but all the clients, interact via API to the cloud. The core application services consists of the core business logic of ESP Rainmaker, and then there are some optional components which are event processing framework and OAuth2 connectors, which we will see further in the slides. Now, the blue box that you can see is actually the cloud which is hosted in your AWS account. We'll see what it consists of in the next slide. So the cloud which is hosted consists of IoT core and SQS in the form of data ingestion. So all your IoT devices, as you can see from the left side, interact via MQTT to the IoT core. And IoT core and SQS form a part to help the device messages go into the cloud. The processing part, which is Lambda, helps in storing this. So whatever device messages are there, it formats it and it stores it into data storage services like DynamoDB and Dynstream. And if you go to the right part, there are voice assistants and mobile apps and also the dashboard. So all the clients interact via HTTPS to the API gateway. So API gateway is also connected to a Lambda which decides what to do when that API is invoked. It may actually interact with the data storage services to fetch some data or write some data. You can also see one Cognito service. So AWS's Cognito service is used to store users and also session management. There is also a service named SES, which is used to send emails. So these are the major services which are used. This is important because only when you know what is currently offered as part of ESP Rainmaker can you think of creative ways to extend ESP Rainmaker. Now, why do you require extending Rainmaker? So, if you see, Rainmaker is pretty complete, and most of the use cases that you have would be already there in Rainmaker. But there may be some specific things which are only applicable to your product. In that case, you can always realize them via extending Rainmaker. So, some of the examples which are listed here are integration with external applications like ERP or CRMs. So you would have your own ERP or CRM systems wherein you need to ingest data or get data or do something there. Then there would be analytics based on the events, do some analytics for your business. Then there would be integrating with third party authentication systems. In case you have your own user management system, you can integrate it with Rainmaker. Or some custom APIs wherein you need something more from Rainmaker, and additional processing for MQTT messages, which is specific to your product, and also storing audit logs for regulatory compliance, which is specific to you. So these are some of the examples for extending Rainmaker. There may be many more, and we would love to hear what creativity you have and what things do you try to extend Rainmaker. So these are the common ways that we think you can extend Rainmaker with. One is the event processing framework, second is the custom modules, and third is the OAuth2 connectors. So event processing framework is nothing but every time there are events generated in Rainmaker due to some users, APIs, or device messages, in that case, you want to do some action. Custom modules is having more modules on top of the Rainmaker stack. And OAuth2 connectors is to bring your own identity management users into Rainmaker. So we will see these three ways to extend Rainmaker. And as I said, there may be many other ways. So this is just the top ways. So event processing framework, basically Rainmaker events trigger custom actions. There are multiple events which are generated in Rainmaker, which will then trigger custom actions. These actions will be defined by you based on your requirement. So to go to the actions part, we require events. So what are Rainmaker events? So Rainmaker events are generated in the Rainmaker cloud as a result of user actions or device messages, either when a user calls an API or when a device sends some messages. So there are 16 events which are currently supported, but we are keen on increasing this list, and we will keep adding more events. Most of the important events are like node online or offline, that is the device is disconnected or connected. Then node association, which is when a user has got a new device. Node parameters changed, which is light getting switched on or off. Node automation triggered, tags added from or removed, which is kind of a searchable criteria for your node. Some parameters are to associate with the node. And then there is node configuration changed. So these are some of the important events. There are many more, and you can check it out at the GitHub link, which I will provide in the further slides. So these now that we know what events are, we'll go to what actions can you think of to that these events can trigger. So the events can trigger any custom action, and the mediator between is an AWS Lambda. One event can result in multiple actions. In that case, there will be multiple lambdas which are subscribed to those events. And some of the example actions that we come up with would be sending emails to your end users, sending push notification to users, creating a webhook to integrate with third-party applications, analyze user patterns, or integrate other AWS services when an event is generated. So just to give an example, we can say the event is light is getting connected or light is getting disconnected, the light device. So in that case, you can have an action. We at Rainmaker actually use this framework to send push notification to users, wherein we say that, okay, your light is now online or your light is now offline. So this can be one example which we take. There can be many more. So the framework, as we already know, consists of an AWS Lambda function which listens to the event SNS topics, and it then triggers the actions which are defined in the code of that Lambda. And the core business logic which defines what to do with that event goes into the Lambda code. The entire flow, if we just recall whatever we have seen till now, it is basically, if you go to the events part, there are two entities involved, which is user and device, which send messages or requests to API and MQTT, which then triggers their respective lambdas. There is some part called event filters, which is an advanced concept, and we'll get to it at the end of this section. So the events which are triggered go to that SNS topic, and this SNS topic is actually subscribed to the event processing lambda. So whatever your event processing lambda is, that will require permissions to access all the 16 event topics that Rainmaker provides. And then it can do anything, any custom actions, which can be, as discussed, sending SMS, emails, doing some analytics, push notifications, or webhooks. This is the entire event processing framework. So let us now understand what Rainmaker provides for you to get started with the event processing framework. So there is a sample project at this GitHub link, which is provided on the screen, wherein you can just clone that repo. It consists of a sample Lambda function, which is developed using Python, and this listens to the SNS topics, which are Rainmaker events. It then processes the payload and it just prints it in the CloudWatch logs. So this is just a kind of a sample function which you can extend further to do custom actions. And an evolving list of all the supported events which Rainmaker supports is available on the GitHub page, and you can check them out whenever you're developing them. So the tools and technologies that you would require to start customizing the event processing framework would be AWS CLI, AWS Lambda supported programming language, which would be like Python, Go, Java, or Node.js, and AWS SAM CLI. So as Rainmaker uses serverless architecture, there is something named serverless application model in AWS, which is used for developing serverless applications as infrastructure as code. So these three tools are mostly required for developing any serverless application, and you would also obviously require them for developing the event processing framework. The detailed steps of all the development and how the deployment is to be done are available on the GitHub page, and you can then extend the code once you are familiar with the process in which to build and deploy the code. So let us now go to the demo part, wherein we'll see the actual sample function in action and see how it prints the log whenever a node is connected. So let us go to the demo. As you can see in the screen, there is one terminal window where I have cloned that public GitHub repo, and it consists of this webhooks template Python, which is the Lambda function which prints the event that it gets. There is this template.yaml, which is a SAM template which defines all the resources which are required. So this is the repo, and I have already deployed the code. So this is the GitHub link which gives all the details regarding how to develop and deploy the code. We can go to the GitHub page, and there are three commands which needs to be entered. One is SAM build, then there is SAM package, and then there is SAM deploy. So once you are in this repo, you just have to SAM build, SAM package with this command, and then SAM deploy. And then your code would be deployed to your AWS account. So if I check this here, this is the stack that got deployed. It consists of these resources, which are nothing but the Rainmaker event SNS topics and the permissions. And it consists of this Lambda function. So now that we know what it is, let us try to test this event. I already have an ESP32 board which is connected to my local environment, and I will just connect it using the IDF command idf.py monitor. Okay, so till the time this is getting connected, let us go to the CloudWatch logs and see if we have any events. Okay, so we have this event wherein if we check, this is Rainmaker event node connected. So this is the payload that Rainmaker sends to the Lambda function. Then there is an ID and event type, which is node connected, timestamp, some description, and then there is event data, which consists of all the parameters and other things which you may require. So now we have seen the entire end-to-end flow, wherein the event that we triggered was getting the node online, and the action that we did was to print the CloudWatch logs. So now we are done with the demo. As I have mentioned before, there is one advanced topic, which is event filters, which you can use to optimize the events which are posted to the SNS topics. If you feel that there are some events which you don't require, in that case, you can filter them. And this filtering can be done at three stages, which is system, user, and node. So the event filters can be configured using the Rainmaker dashboard or using the Rainmaker APIs. The Swagger link is provided in the presentation. So this is the event filters flow, wherein the event source is actually filtering at system, user, and node level to reach the SNS topic. And system level filter is kind of a master switch, wherein you can say that I don't want any node connected event in my Rainmaker system. Then there is a user level filter, wherein you can say that I don't want node connected events for this particular user. And node is also selecting if you want it or you want to disable it for that particular node. So in case your event processing framework doesn't require node connected, you can say that I want to disable them at system level. So this is the infrastructure that Rainmaker provides so that you can choose which events you want and which you don't. We'll now go to custom modules, which is the second type in which you can extend Rainmaker. So custom modules is custom development on top of Rainmaker. So it will consist of serverless architecture and some modules which will be there on top of the Rainmaker deployment that you have in your AWS account. This may be required to build additional custom logic, maybe additional APIs or additional logic to process the MQTT messages. the custom modules that you develop will actually be on top of RainMaker. So they need to follow similar architecture, and this will actually fit into the overall paradigm of RainMaker, wherein it will have serverless services used. So there is this sample custom module which is provided at the public GitHub of Espressif Systems, which actually demonstrates development of a sample API. And the project which is there, it consists of an API gateway resource. It consists of a Lambda function, a sample DynamoDB table, and SAM templates to deploy all these resources. So this will help you to get kind of a boilerplate code wherein you can add other features on top of it. And obviously, the development is not restricted to the resources which are provided in the GitHub repo. You can add other AWS services which you require. And just a note of caution that whatever code that you are going to write in this custom modules, it shouldn't impact the existing Rainmaker deployment. So, say it shouldn't delete the tables which Rainmaker uses, or it shouldn't modify something. That is because in that case, the upgrade process of RainMaker or the way in which RainMaker works may get hampered, and then it will create problems. Just to get an overview, this is the structure that is there in that sample custom modules, wherein there are 4 methods to the API gateway, and then there is a Lambda function which is triggered. So let us now go to the demo of custom modules, wherein we are going to see how we are going to deploy the custom modules. I already have the code cloned in my environment. So this is actually the GitHub repo that was there in the presentation. It consists of this module, which is ESP custom service, which has got 3 stacks to it, which is base API, base, and custom service. And it consists of 2 lambdas, which is API versions custom, which tells the users on which API version they are. And it consists of the custom lambda, which currently, as this is a sample code, just prints in which method it is. So I have already deployed this. This is the command make all and make deploy and name of an S3 bucket which is public in your environment. So let us go to the deployed code that we have. So this is the ESP custom base API, which defines an API resource. And then there is this ESP custom base, which defines a table. And then there is ESP custom service, which defines a Lambda function and 4 methods. So the API, we can actually see it in the AWS console, wherein we have user/custom, and there are 4 methods, which is put, post, get, delete, and also an options method for core settings. Now to test if this is working, let us just go to the curl command, and if we just click it, we can see that we get the output from the get function. This was it for the demo of custom modules. And you can do many interesting things here according to your business requirement. So let us now go to the presentation. Okay, so far we have covered event processing framework and we have covered custom modules. The third part, which is OAuth, will be covered by my colleague Deepak. So handing over to him.
Thank you, Manali, for handing over to me. So myself, Deepakumar. So I'll be going over the OAuth 2 connectors. So I'm working in the Espressif team as a cloud backend engineer. So let's just jump on. OAuth 2 connectors. So what is OAuth 2 connectors and why we need it? So this is the first page when what the end users would see in a mobile app that is developed using RainMaker. So in this mobile app, the users can sign in or sign up using the email or password, or they can also use their Google accounts to sign in. What if you want your own identity management system to be integrated with RainMaker so that your users will have a seamless experience accessing ESP RainMaker platform? Well, there is a solution to it, and that's OAuth. So before moving forward, let's just understand how the authentication in RainMaker works. So in RainMaker, we use something called as AWS Cognito service that is used for user management and authentication. It's a serverless service provided by AWS. Cognito has already built-in support for social logins like Google, sign in with Apple, login with Amazon, and Facebook. And we can further extend it with OpenID Connect. what is OAuth 2 and OpenID Connect? OAuth 2 is an industry standard framework for authorization. Before OAuth 2 existed, or whenever a user wants to share information that is belonging to one website to another, the user needs to share his credentials with him. But currently, with OAuth 2, the user doesn't need to actually directly share the credentials with the other website. He can generally pass a token. And using this, the access of data is granted. Now, why OpenID Connect is needed? OpenID Connect is built on top of OAuth 2 to actually handle the authentication layer. As we move on to the next slide, we will now see how the OpenID Connect flow will look like. So here we will start from the left hand side where it's written login with corporate ID. So here the login with corporate ID can be your own authentication system. So users will click on that, they will be redirected to your login interface. Here the users will enter the user ID and password. Once they enter the correct username and password, they will be redirected to a page where that will be requesting the consent of the user to share the particular information. Here, in case of Rainmaker, this data would be the user information. So this user information will contain the user ID, user name, etc. that are used to actually uniquely identify a user. Now, once the user says that, okay, I allow to share the data, then this particular UI will redirect to Rainmaker. That is a callback URL which will take this data, get the token from your system, get the user information from your system, depending upon the scope the user has provided, and Cognito will see if the user exists or not, create a user, and authenticate the user and provide the access tokens through which users can seamlessly access the Rainmaker platform. Now, we have discussed the flow of the OpenID Connect. Now, there comes a question where why we need OAuth connector at the first place, right? So, why we need the OAuth connector? So, OAuth connector acts as a wrapper around your OAuth framework and the Cognito's OAuth framework. This is mainly because some of the user authentication systems like GitHub or any other systems have some caveats along with their OAuth system. For example, in GitHub, you need to call two APIs to actually access all the data that are required to uniquely identify a user, which is currently not out of the box supported by AWS. To do that, we have provided a custom module that actually does all these handling for you, and you can directly start using your OAuth connectors. And this module is already available in the serverless access repository, which is like a Google Play Store or an App Store for applications, and the access to this particular repository will be provided on request basis. So now, as we have done with all the explanation of how the OAuth 2 and why we need the OAuth 2 connectors, let's jump on to the demo. So here we see the serverless application repository loaded. So let's just search for our OAuth 2 connector. So here we have our Rainmaker OAuth 2 connector. So let's just click on that. So after clicking on that, a particular page will be loaded here. So this is the OAuth 2 connector. So in this demo, we will be seeing how to integrate GitHub. So we will be actually filling all the details that are required for the GitHub. So here we have the stack name, we have the authorized URL, we have the email URLs, we have the token URLs, and we have the user URLs. So this user URL is to access the user information. This token is to get the token. Emails is used to get the emails of the users to uniquely identify the user. And we have the authorized to actually initiate the OAuth flow. So once we have filled all the required details, we will click on deploy. So as I've already deployed the stack, I will be not clicking it now. So let's just move on and see the output. So this is what the output will look like after deploying the stack. So we have serverless repo, ESP RainMaker OAuth 2 integration. And if we navigate to the output tab, we have all the information that are required for you to access seamlessly to integrate the Cognito with your own identity provider. So the next step to create a OAuth 2 application in GitHub to actually facilitate the connection between the two. So here I have already created a OAuth 2 demo connector with us, and we have already the client ID with us, and we have the client secret with us. And if we scroll down, we would see that this is the homepage URL. I have kept it to Espressif, and this is the callback URL. This is the URL to which the GitHub will send the code back to. so that we can have access to the token and user info. So now, as we have already configured it, let's just jump to the Cognito. So here in Cognito, I have already added the client. So this is the Espressif demo app. There is client ID, there is client secret, and we have posted all the URLs that were present in the CloudFormation output. That is the authorize, token, JWKS, and the issuer URL. And we have also provided some attribute mapping that are provided here to actually facilitate the mapping between the attributes that are provided in GitHub to the attributes that needs to be stored in Cognito. This list can be extended further depending upon the customer's needs. So once this is done, let's just start testing it. Right. So this is the hosted UI that we have. So this is the particular Espressif demo app. Here you can have your own particular identity system here. So once the users start to click on this, so they will be redirected to the GitHub login page. So as you see here, we are trying to log in to GitHub to actually give the access to Espressif or RainMaker. Let's just do the login. Okay, so now we have done the login. So it's going now to ask for the authorization. So as I've already done the authorization and I already provided the access, so now we have actually logged in to the RainMaker. So how we can know that? So we have received a code here which can be facilitated further to actually get the required access tokens from the Cognito to actually seamlessly call the APIs. So this is with the demo. So let's move on to the presentation again. So now, so as we have seen with the demo on how it actually seamlessly integrates Cognito and GitHub, now this module is also available in GitHub for further customizations. So the link provided here is for the GitHub link. Further, there are detailed steps to actually configure OpenID client in AWS Cognito as well. We have come to the end of the talk. We hope this talk was useful in letting you know how to extend RainMaker to meet your business needs. All the resources are publicly available in GitHub. Please feel free to experiment with all the extensions. If you have any additional questions, we would be happy to help. Thank you and enjoy your day.